This video is on operations on radicals, or I should probably say operations with radicals. It's an Algebra 1 review in preparation for work on radical functions. So in Algebra 1, one of the things we learned how to do was to simplify radicals. That means not plug them into the calculator and write down a decimal equivalent. I want an exact simplification. This is how I learned it in Algebra 1. My teacher said, rewrite the number under the radical as the product of two numbers, one of them being a perfect square. Well, remember what perfect squares are. 4, 9, 16, 25, 36, 49, 64, 81, 100, numbers like that. Well, it turns out that 9 goes into 18 two times. There is a property on radicals that says that if you have a product under a radical, you can separate that radical over each factor. And now, the square root of 9 is something I can take. It's 3. But I can't take the square root of 2 without getting a decimal, so we say the simplified version is 3 the square root of 2. But there's another way you can do it. You also can rewrite 18 in prime factorization. So, do the little factor tree. You would get 2 and 9, and then 3 and 3. So under the radical, you would write 2 times 3 times 3. A square root is something you take when you have pairs of numbers, because in algebra, square is 2. So I have a pair of 3's. That means that I can take out a 3. And I'm left with 3 on the outside, but I couldn't do anything with 2 underneath, so it stays underneath. Let's do this again using the square root of 72. If you're going to do it in method 1, the way I showed you by finding the largest perfect square, you have to be careful, because sometimes there are more than one perfect square that divides into a number. You want the largest perfect square. It turns out with 72, 4 goes into 72 18 times. And it turns out 9 goes in 8 times. But if you keep dividing 72 by the perfect squares, you'll also find out that 36 goes into 72 2 times. So there are 3 perfect squares that divide evenly into 72. The thing is, we want to use the largest perfect square, which happens to be 36. So then I would rewrite this as the square root of 36 times the square root of 2, and the square root of 36 is 6, so it simplifies into 6 square root of 2. What if I had done this using the factor tree? Alright, how about I use 9 and 8, because that's usually the pair people come up with first when doing prime factorization on 72. So 9 breaks down into 3 and 3, so we're done with that. 8 is 2 and 4, but 4 is 2 and 2. So, in prime factorization, there are 3 2's and 2 3's. Well, I want to circle any pairs I have. Well, I have a pair of 2's and I have a pair of 3's. So that means I can take out A2 and A3. What do I do with those numbers? I multiply them. And 2 times 3 is 6, but there was a 2 that I didn't circle, and there we go. Now let's talk about operations on radicals. That means adding, subtracting, and multiplying. We'll cover division another time. Adding and subtracting radicals works just like adding and subtracting like terms. When you add x plus x, we get 2x, not x squared. Remember, x times x is x squared. X plus x is 2x. So, if radicals work like terms, then the square root of x plus the square root of x is 2 the square root of x, because there are 2 square roots of x's. Now, in order to add radicals, what is under the radical, the radicand, has to be the same. So if I gave you 5 the square root of x plus 3 the square root of y, I want you to notice that what's under the radical is not the same, and therefore this could not be added and this would be completely simplified. There is no further you can go. If I give you 5 the square root of x plus 3 the square root of x, now they are like terms, and so we can add them, and you only add the coefficients. And it doesn't matter what's under the radical. So if I change this to be 5 the square root of 3xy plus 3 the square root of 3xy, as long as what's under the radical is the same, you add the coefficients. And notice when we add, we're not adding what's under the radical, we're just adding the coefficients. Multiplication of radicals works a little bit different from adding and subtracting. Adding and subtracting, you only worry about the coefficients. Multiplying, however, as long as both numbers are under the radical, you can multiply them together. So if I gave you the square root of 2 times the square root of 3, you would tell me it's the square root of 6. So when you're multiplying, they don't have to be the same, but if you're adding, they do. But you have to be careful, because if I gave you this problem, this is not the square root of 6. This is just 2 the square root of 3. The only time you can multiply together what's under the radical is if both terms are under a radical. Whereas in this example, 3 is under a radical, but 2 is not. Therefore, I can't combine them. I can just smush them together into a little multiplication problem. Don't be fooled when you get an addition or subtraction problem about what's under the radical, because it turns out that the square root of 12 plus the square root of 75 can actually be added even though what's under the radical is not currently the same. That's because if we actually simplify both of those radicals first, then I will be able to add them together. So watch this. We did the square root of 12 earlier. We found out it was 2 square root of 3. So I'm not going to redo that problem. But the square root of 75 I am going to do. There were the two ways of doing it. One of them was to rewrite it as the product of two numbers, one of them being a perfect square. So since the square root of 75 is the same thing as the square root of 25 times 3, that's the same as the square root of 25 times the square root of 3, which is 5 the square root of 3. So this is one way you can do the problem. Or the other way is you can do the factor tree. Yeah, I want to do that. Yeah, do this. And now I've got the square root of 3 times 5, and since the square root is looking for pairs, here's your pair of 5s, which means you take out the 5, and it's still 5 the square root of 3. And now that they have the same number under the radical, I can add the coefficients. Oops, get rid of that plus sign. And it's 7 the square root of 3.